So give your parents their money's worth here. So, who's got one? Who's got one written down? Olivia.
Okay, the vertex is -1, 2. It contains the point 23.
All right, so we've done one of these already, but I think she's right. This is one of those that kids miss on test day. So your job is to write the equation of the parabola given this information. Now, before you get started, just pause for a second and think, all right, write the equation of the parabola. My answer is supposed to look something like this. That's what my answer is supposed to look like. That's what you're shooting for. If you keep that in mind, I think you can at least get started. Because where's the vertex of this? The vertex of this one would be -5, -7. So think backwards, x plus 1 squared plus 2. Everybody with me? Now, they didn't give you this for nothing. There's a reason you have this information. You need to plug in that point to figure out that leading coefficient. So 3 equals n times 2 plus 1 squared plus 2. Putting in 3 for y, this is x and y. So 3 equals, be careful on the arithmetic, 2 plus 1 is, well, 2 plus 1 is 3, but squared is 9, so that's 9n. So n is 1/9. And the answer that goes in the answer blank is a 1/9 right here. That's it.
Can you go through like the multiplication with the
This right here, you?
Yeah.
Okay.
You got 9n.
2 plus 1 is 3. Squared is 9 times n, 9n, and then plus 2. These don't add those. This one's the n's. So it's 9n plus 2. Okay? Okay?
It's the
Next problem.
It's find the rational roots and then find the roots with the quadratic formula.
Okay. So I gotta read this one just a second. Okay, so the problem is f of x equals x cubed these you can't just make up, plus 7x squared plus 13x plus 3, and I hope I didn't make a mistake. I hope that's right. We're going to find out. So the directions say find the possible rational roots, and I'm probably going to write that out, possible rational roots, but you're thinking of those as PRRs, find our PRRs, and then find the actual roots. So it's a two-part question. Given this function right here, we're going to find all the possible rational roots. Okay, we know what that is. Plus or minus 3 and 1 over 1. Factors of this number over factors of that number.
Try 3.
So
Or -3.
Now, we got Olivia over there, and she's always working at lightning fast speed. She's always ahead of us, throwing out hints, which is great. But she won't be doing that on Monday. Or if she does, she's in big trouble. So you're going to be guessing numbers. I am going to guess, I'm going to guess -1 first. And this is not looking good. Right? That didn't work. Now I want to give you just a little bit of a hint here. see how all those numbers are positive right there?
Yeah.
If I put a positive number here, is there any way I'm ever gonna get 0? Think about it for a second. If these are all positive, and I put a positive number there, won't everything up here be positive?
Yeah.
And then it'll never give me a 0. So I'm not gonna do net positive 1, I'm gonna do negative 3, because negative 1 didn't work. So negative 3, oh, there we go, that works.
Wait, when you do the quadratic formula out of things, do you have to put both of them, or can you leave them in plus or minus form?
You can leave it with plus or minus 1.
Keep it.
All right, now, she's ahead of us still. My direction said find the roots, so one of the roots is negative 3, because it gave me a 0 when I divided. Right? What are the other roots? Well,
You gotta factor.
x squared plus 4x plus 1 is what's left. And on every problem on the test, except one, that's going to factor. But there's one problem where it's not going to factor. This doesn't factor. So what do we do if it doesn't factor? The quadratic formula.
Could you complete the square?
You could complete the square if you wanted, absolutely. Negative b plus or minus the square root of b squared minus 4ac all over 2a.
Square root of 12.
You're gonna have to be careful with this one
Root 2, root 3.
because it reduces. If you want full credit, you're not going to stop here. And if you want full credit, you're still not stopping
2 plus or minus root 3.
because all of these are divisible by
Negative 2 plus or minus.
2. So the other answers, we have one answer is negative 3. The other ones are negative 2 plus or minus root 3. And those are your 3 answers.
So you get the possible rational roots from the first and
Factors of this over factors of this. Okay, Jalen?
That one, the height one.
The height one?
Yeah.
So Jalen wants to practice one of those problems where we throw the ball up into the air. And we want to know, it's a 2-part question. When does it get to the highest point? And what is the highest point? Okay, and so the equation you'll be given, it'll be written in function notation probably. Actually, let's,
Isn't it minus 32?
no, I'm gonna make some, I'm gonna put a different number in here. All right, so here we go. Got it, the height of a ball above the ground is given by this equation. We wanna know when it's gonna get to its highest point and what that highest point is going to be. So the things that are floating around in our minds are, that is a squared equation, which automatically means it's a parabola. It has a negative in front, which means that it's a parabola opening down. The question has to do with the highest point, which is just another way of asking for the vertex. You know how to find the vertex of a parabola. The vertex of a parabola is negative b over 2a, or the x-coordinate is negative b over 2a, which for us would be negative 48 over negative 32, which reduces to 1.5. So that vertex has an x-coordinate of 1.5. Ava, I'm gonna make you a deal. I'm not gonna scream and yell at you when you get an A on this test, okay? But if you don't get an A, I'm gonna be screaming and yelling at you. That's got to stop. So, Brooks, I don't know what your role in it is, but stop it. Okay, so 1.5 is my x-coordinate. How do I get my y-coordinate?
Plug in X.
Plug in x. And you're going to have a calculator to help you with the arithmetic if you need it. So I'm doing it without a calculator because I don't have one out right now. But I'm sure you're going to help me. You should have gotten 44 maybe? So we have our vertex. Okay? Now we're going to answer the questions, and there's 2 of them. When does it reach its highest point, and what is the highest point? Now, one of the answers is 1.5, and one of the answers is 44.
A is 1.5.
A is 1.5 seconds and 44 feet. T is the X. This is your seconds. This is your feet. Y is your feet. Okay, Jalen?
Yeah.
That makes sense? That is not a hard problem. I know it's a word problem, but it isn't hard. Highest, maximum, whatever vocabulary they use means vertex. Find the vertex. James Wayne.
I was going to put the next one.
Yeah.
Temperature varies inversely.
Okay. So we're going to do a variation problem now. So let's say algebra varies inversely as geometry. If algebra is 9, then geometry is 20. Find geometry if algebra is 16. Now that's a nonsense problem, but it makes no difference. The math is the math. So you think immediately when you see this word, you're thinking y equals kx, y equals k over x. When you see the varies problem, you're thinking those 2. So then you look at this word, and it tells you we're doing this one. But my advice to you is, let's not do it with y's and x's. Let's do it with a's and g's. Notice which one I wrote first. The one that comes first. Algebra varies inversely as geometry. So this is the equation I'm using. Does that make sense to you, James? So now we'll look at the next sentence, and it will tell us to plug some stuff in. Algebra is 9 when geometry is 20. So that tells me that k equals 180. Just solving that little equation. So if k is 180, it's always 180 in this problem. So I'm putting k right here. So A is 180 over G. If algebra is 9, oh no, I already did that. Find geometry if algebra is 16. Find geometry if algebra is 16. Does that make sense to you? Now when I solve that, don't get crazy. Get rid of the fraction. 16g equals 180. So g is going to equal 180 over 16.
11.25.
reduces to 11.25 apparently.
Can we keep it as a very simplified mixed number?
Absolutely. It has to be reduced though. So you wouldn't want to leave 180 over 16, but you can reduce that fraction. All right? Who else has one we haven't talked about yet? Who else thought of a problem we haven't talked about? Bo.
Change to vertex form by splitting square.
Okay. So we practiced one of those earlier. Let's do another one because this is one that we miss a lot. And notice the directions, if you heard him say, by completing the square. So it's not just the answer that I'll be looking for your process. So it'll look something like this, I would imagine. And we're going to complete the square, which means ultimately we want to have an equation that looks like this, right? That's what I'm shooting for. So what do I need to do first? Divide by 3. And I'm going to physically divide every single thing by 3. Divided by 3 all the way across. Move the 4 to the other side. Bo, are you following along here? Is this getting what we're doing here?
So far, so good.
So far, so good.
And then this is where
You take B.
Okay, well, don't choke here. This is where we figure out what to add, right, Malcolm? We're going to add something to both sides. Malcolm? What are we going to add to both sides? Okay.
9.
9. Tell Bo how you got 9. That's exactly right.
Take half of -6, or yeah, take half of -6 squared.
Yep. So half of 6 is 3, and 3 squared is 9. And I don't need to worry about the negative because since I'm squaring, it's going to go away anyway. So half of 6, 3 squared, 9. So Bo, we add 9 to both sides, just like Malcolm said. This side right here is always factorable. Factorable. But the 2 parentheses will always be the same. So instead of writing them as 2 separate parentheses, we're just going to write x minus 3 squared. That factors into x minus 3, x minus 3. So we write it as x minus 3 squared.
So you're factoring
This right here. After you add the 9. Johnny?
No, I'm good.
So y over 3 plus 5. On this side, we just go ahead and add these 2 numbers together. Now remember all the stuff you did in the beginning when you moved the 4 over and you divided by 3. Now you're undoing that. So you're going to subtract the 5 back over
Multiply by 3.
and multiply it by 3. And when we multiply by 3, we multiply here and here only. So we get 3x minus 3 squared minus 15. Because we multiply here by 3 and here by 3. Okay, who else? Anybody have another one that we haven't talked about yet?
yeah. Another. Find the vertex act in the same direction.
Okay, it should say in the manner of your choice or something like that. So you can always do the completing the square thing, but you don't have to. So if we want to find the vertex axis, symmetry, and direction of opening. Anybody that misses this deserves some kind of nasty comment on your paper. Because the direction of opening, you don't have to know any math. All you have to do is look at the equation. See, that number is positive, so this thing is going to open up. Now, axis of symmetry. X equals negative B over 2A. Now, don't freak out because there's a fraction. Good grief. What's 2 times a half? 1. So your axis of symmetry is X equals negative 5, which means your vertex is negative 5 comma something, because this is X equals, so the X is negative 5. Right? Now we plug in negative 5 back up here. So we're going to have 1/2 times 25 minus 25 minus 3. So 1/2 of 25 is 12.5. And again, you have a calculator at your disposal. So it looks like I get negative 15.5. And we're done. That problem right there is the ball in the air problem. Same, you do exactly the same thing. Only in the ball in the air problem, instead of writing the point like this number tells you when the ball reaches the highest point, and this one tells you what the highest point is, right? But that problem is done exactly the same way.
Can we do like a weird one that like bounces?
You mean graphing?
That's like 5 zeros or something.
Graphing. So yes, you are going to have to graph a weird, big polynomial, but it will be factored for you, so it'll just be, you'll just have a bunch of factors. Oh, not minus. We're graphing it. We're graphing it. Oh, easy. We're graphing it. So the first thing we do is plot our x-intercepts. And oh, by the way, make sure you label them. That would be dumb to miss easy points because you didn't take the time to label them. Now, you've done enough of these, you know you're either going to come up like this or you're going to come down like this, right? So you got to figure that out. And how do we figure that out? We add up all the x's. How many are there? 6. Normally, even would be like a parabola, like this, right? But because of the negative, it's coming in from the bottom. Now, when it hits that point, it's going to do one of 3 things. It's going to zip right through, it's going to squiggle through, or it's going to bounce off. That one came from this parentheses. So it's just going to go straight through, right? Now it's going to turn around at some point and come down, right? But when it hits that one, it is going to squiggle through. I always have a hard time doing my squiggle, so I gotta, there I squiggled through. Squiggled through. Now it's going to turn around somewhere and come up to here. What's it going to do when it hits that one? Bounce off. There you go. If we go 1 point at a time, you can all do that. That's easy.
What's left?
I don't know. You got to practice.
Why is it squiggling? Because of 3?
Uh-huh. What'd you say, Olivia?
Determining, like, if things under the radical, what are those?
Oh, if it's a polynomial function or not?
Yeah.
Yeah, we all we need to do is review the rules for that. How do we tell, what are the things that make it not a polynomial function? We have a fractional
Negative
exponent, a negative exponent,
Variable under the radical.
variable under the radical. We already said fractional exponent, so fraction exponent, negative exponent, under the radical and in the denominator. Yeah, those are the things that make it not a polynomial. Remember, on that section, it's just like on the practice test. It isn't enough to say no. You have to say why it's no. If you say yes, it's fine. Yes is good by itself. But no, you have to explain why. Okay? So what else? Have we done everything? I don't even remember.
You're just like synthetically applied.
We are going to have to do a synthetic division problem, and
One was 0.
you know I'm going to try to trick you.
Maybe a few of these go.
So there'll be one synthetic division problem where you'll have to do something like 8x to the 6th minus 4x to the 5th plus x cubed minus 2x squared plus 5. And we're going to divide that by, let's say, x plus 1. Now, it seems like half of our problems require synthetic division, so I know you know how to do it. You just have to be paying attention. What goes in the box?
-1.
-1. Now, we'll start with an 8. We notice that's a 6. So we need a 5. We have it. We need a 4. We don't. We have a 3, which by the way is a 1. We have a 2. We do not have a plain X. And then we have our number. Does that make sense to everybody? Eight comes straight down. This number comes straight down. Draw that arrow to remind you, comes straight down. So here we go. That's -8, -12. Now, I'm kind of careless on this, so I'm going to stop and see if that's what you got. On the test, there will be 2 answer blanks here. One will be for the quotient, and one will be for the remainder. Remember, in the division, this number is the remainder. So the remainder blank is going to be 14, or if you want to write 14 over x plus 1, that's fine. That's the remainder. Now, what goes in the quotient blank? 8x to the 5th. 12x cubed. 11x squared. Plus 9x. Minus 9. Okay? Now, make you people a deal. Because I feel terrible. Oh, we're having a test. But I feel terrible about the fact that it's not till Monday. So since you have late arrival in the morning, and I don't have a meeting in the morning, if you want to come in tomorrow at regular time and take the test, you can.
Oh, God bless.
The only thing is, I need to hear from you, so I know if I need to be in the room, because otherwise I'll be in the weight room on the elliptical. So if anybody wants to come in, you need to tell me. Olivia, you're telling me? All right, so I will be here.
How long will the test take, do you think?
Well, here's the deal. We're not